Welcome to my world. Another day, another time, another period for acquisition of knowledge. Knowledge is power, health is wealth. My effort today is centered on the SOT titled Salt Good or Bad Laboratory Finding. The reason for this is we are told that salt is essential. Normally you hear this very well, that salt is very necessary for the body, but at the same time you are now hearing at a certain age that salt is not good for you, that you should avoid too much salt or avoid salt even in your food. You now start wondering, is salt really good or is salt bad? So this effort of mine is to clear any misconception on salt and let us have the true knowledge about salt using the help of the laboratory to understand more salt that we take. I will always request you to please subscribe, because your subscription is the only way. Subscription is free. Subscription, just press the subscribe button. Notification bell, you can also press it, and like the production if you like it. Thank you. I have put a case study of salt in the Dead Sea so that we can understand how salt could be detrimental to our health when we really take salt. Salt good or bad? Lab findings. The outline, objective, introduction, case study of Dead Sea and freshwater, laboratory findings, and recommendation. The objective: to correct the dialectic that salt is an essential spice necessary for the body, and at the same time some people are warning that salt is dangerous for one's health and not necessarily addictive in food. That is the objective. Introduction: salt are molecules that break apart in water to form ions. Ions are those things necessary for conductivity, electrical conductivity. They also exist as mineral salt, as rock salt, a deposit of mineral formed from the evaporation of salt water in partially enclosed basin. The term salt is also applied to substances produced by the reaction of acid with a base known as neutralization reaction. Salt are characterized by ionic bond that I mentioned, relative high melting point, electrical conductivity when melted or when in solution, and a crystalline structure when in the solid state. When your body becomes low on electrolyte, it can impair your body's function, such as blood clotting, muscles contraction, and acid balance and fluid regulation. Your heart is a muscle, so that means electrolyte help regulate heartbeats. So that is also a takeaway. Salt is necessary to human life because they not only add a flavor to our food, but also the sodium and chloride of salt along with potassium are electrolytes which help the kidney regulate the body fluid level and the balance of acid and base. Osmosis. Osmosis could be used to explain how all organisms regulate the amount of salt in their tissue. In the biochemical processes of osmosis, water moves through membrane that surrounds each living cell from area of lower salt concentration to area of higher salt concentration. So that becomes very useful in this case study of salt bad effects. The Dead Sea is a very good example of the bad effect of salt. You can see that nothing can live, and that is because the lake is fed mainly by the Jordan River, which enters the lake from the north. It has no outlets, and the heavy inflow of fresh water is carried off solely by evaporation, which is rapid in the hot desert climate. The Dead Sea contains some 27% of sodium chloride and many other substances which increase the density of the water. The human body easily floats on the surface. That is instructive. Salt is hygroscopic, that is always drawing water from the surrounding. Salt contains no life. So it contains no life of any sort except for a few of microbes sea fish put into its water. So that is instructive for those who take excess salt. You can understand that when you take excess salt, the salt itself is injurious. You can experiment with worms, the earthworms. When you put salt on them, it divides them, it dries them up. So let us understand that too much salt in the body really cause more harm, just like the Dead Sea cannot support any living cell on it. Why are there wrinkles on the finger if we swim in fresh water? The freshwater case is also a very good example. When human bathe or swim in fresh water, osmotic pressure, the same osmosis, causes water to pass slowly through their skin into their tissues because the body fluids are saltier than the fresh water outside. This causes the body to swell, what we call edema, and produces the wrinkles on the fingertips. So you can also understand the antidote against wrinkles. Salt could also be linked. That is a study which I may try to explain in future. That's laboratory findings. The kidney has millions of nephrons that filter blood and produce the filtrate, urine. The filtrate then enters the renal tubule, beginning at the proximal convoluted tubule, followed by the loop of Ehlers, then the distal convoluted tubule, and ultimately into the excreted as urine. As the filtrate travels through the renal tubule, some of it, especially sodium ions, is reabsorbed back into the vascularis, while others new content is secreted into the tubular system. This is where salt concentrate. The sodium pump or sodium ATPase pump is used by the kidney to maintain sodium and potassium balances, acid balances in the body. It also plays a role in maintaining blood pressure, and controls cardiac contraction. You can understand when sodium is retained, that will really cause the volume of the blood to swell. And this is just the nephron that we are talking about, how the water flows through the nephrons and then it is reabsorbed back into the arteries. So that swells the volume of the blood and usually cause high blood pressure. So the sodium pump could be explained later. Is a kind of active transfer that happens. Is different from the osmotic pressure, though usually the osmotic pressure would move water in the direction of the sodium because sodium would draw water, but at times the cell itself push the sodium out. That is what is meant by sodium pump. This which is explained here, the energy use, the 1 ATP used to pump sodium. You can see the picture really explains the shape, the earlier shape of the membrane of the cell. The intracellular cell contains sodium, so it's being pumped out for potassium to come in. The sodium potassium pump is needed to maintain nerve cell voltage and also to drive other transport processes, RTP, which uses the energy to exchange free sodium for potassium. That is to also explain the usefulness of salt. The electrolyte test is what is usually done in the laboratory when we collect the blood sample, venipuncture, and pass it through the machines, and the readings shows sodium, the normal value of sodium as 136 to 144, potassium 3.7, and like that. And once it's very high, there is a need for it to be brought down. So usually through hydration. The person is dehydrated. That's why the salt level is so high. So it happens in dehydrated person. And when this sodium level is low too, it's indicative of people having problem with the edema, and also a situation of probably where the salt intake is not enough, but the body will always perform its role in maintaining that balance. Recommendation. The recommendation is sodium chloride or table salt is approximately 40% sodium. So when you are taking it, you must know that it is 40% of every salt you are taking that is sodium, the sodium ion. So by this you can easily calculate all this. If you calculate 1 tablespoon of that is 40% of 1 tablespoon of this, you will be able to know. So don't salt food before you taste it. Enjoy the natural taste of food. There are alternative flavor and spices to salt that are available and will not shoot up the sodium ions. There is bay leaf, curry powder, garlic, ginger, etc.